Today we're learning to change the subject of the formula, and the formula could be a formula or could be an equation that we're trying to change around. Often in mathematics what we find is that we're given a formula that doesn't directly allow us to calculate what we need to, and we need to then rearrange the formula to allow us to calculate what we want to get directly. Okay, this rearranging is called changing the subject of the formula, and it's one of the topics in National 5 mathematics. So what I'm going to do is I'll probably do 3 videos, I think. First one's going to be looking at linear equations. Second one, we're going to be looking at formula that's going to be involving simple square and square roots. And beyond that, we'll be looking at some problem solving through changing the subject of the formula. So let's get started anyway. I'll try and keep the video short. And what we'll do is we'll talk about some of the aspects related to this. So let's look at a kind of simple problem, something that we all know, and it's around about the area of a rectangle. So I guess we all know at this stage the formula for working out the area of a rectangle. So we know that the area equals the length times the breadth. So if I've got a length and a breadth and that's given, I can work out how much space this takes up by working out its area. So the formula that I'm given for this would be area equals length times breadth. So all I need to do is to substitute my values in. So that's going to be 8 being substituted in for the length. The breadth I'm going to substitute in 3. And for there I'm going to get 24. And the units are centimetres squared, okay? Okay, so that's the way that we would work that out just going normally. But sometimes what we're asked to do is we're asked to find the length, the missing length of a rectangle when we're given its area and its breadth, okay? So if we look at this one here, 44 centimetres squared, square centimetres, in there for the area. I've got one of the sides is 4. I'm sure you can work that out in your head what length that side is there. What we're really interested in this video is trying to change the formula around. So let's start with the formula and then we'll use it to calculate out the missing length. So we know that the formula that we're normally given is area equals the length times the breadth. So I'll just write A equals LB there. Right, so what I want to do and the way I like to do it to change to the length is what I'm going to do is I know that A equals LB. So LB must equal A. So really what I try and think of doing is just swapping things over. Or if you think about it this way, I'm going to have LB equals A. It's just so that I've got the length on the left-hand side of the equation so that I finish up by saying L is equal to, okay, at the end. So if we think about what we did with our equations, solving equations work, then we're going to do the same thing to the left-hand side as we do to the right. So I don't want that B there. That B is multiplying with the L. So what I'll do is to get rid of that, I'm going to divide by B on this side here. And I'll divide by B on the right hand side. So what that should leave me with is L is equal to A all over B. So if I look at that, that's me got a formula that I've rearranged to say that L is equal to. So the length is equal to, so I've got a formula that can work that out for any area that I'm given and for any breadth that I've given. So let's go and work the length out, given the area and the breadth. So I'll substitute into the area 44. I'll substitute into the breadth 4. 44 divided by 4 works out at 11. And we're working in centimetres, so it'll be 11 centimetres because it's a length, isn't it? So I know you could have worked that out in your head and got the answer, but the main thing that we're looking at today is changing the subject of the formula. And that's the way that we would do it for something simple that you already know. Okay, let's move on and we'll see if there's something else that you already recognise as well. So what we have here is we've got something else that you've worked on recently. And what we've got is the circumference of a circle we're looking at. So if you can cast your mind back to what the formula for the circumference of a circle is, well, it's going to be C for the circumference is equal to pi is times the diameter. What we'll do with pi is we'll use, for pi, we'll use 3.14 just for this calculation that's here, okay? Just to make things a bit simple. So similar to what we did with the rectangle, if we go and work out the circumference all we would do is substitute the values that we know. So we know that the diameter runs all the way across and through the centre of the circle. Okay, and to work out the circumference, which is the distance all round the full side of the circle, that's going to be pi times d. So if I substitute my values in, pi times d, which is 2 centimetres, so 2, I should have put in a 3.14 there, I'll just do it now, times 2, and if I multiply that out, I should get 6.28. We're working in centimetres, so that's centimetres. So the distance all the way around the circumference of that circle is 6.28 centimetres. Right, so we're working on changing the subject to the formula. So sometimes what we might want to find out is find the diameter of the circle when we're given a circumference. So I want to know what distance that is all the way across and through the centre of that circle there. So I'm going to start with my formula. So C is equal to pi d. Okay, that's a formula for the circumference. I'm going to swap it round just like I did with the rectangle, and I'm going to say that instead of C equals pi d, I'm going to say pi d equals C. So if I just go for here and go and write pi d equals C. Okay, what I'll then do is I don't want pi on that side there. Okay, so what I'm going to do is I'm going to just divide by pi, and what that should do is cancel this part out here. Pi is just a number, remember, or a letter if we're using it in an equation or a formula. So d is equal to c over pi, and there's my final answer. So the diameter, if I want to work out a diameter, all I'll do is I'll take the circumference and I'll divide it by pi. So let's go and do that one just now as well. So the circumference, as said, all the way around the circle was 314 centimetres. So 314 centimetres, and I'm going to divide it by pi, and we're going to use 3.14 for pi. Okay, I've just used kind of pretty simple numbers. So that would work out to be 100 centimetres as a diameter all the way across. Okay, right, so I want you to have a turn. So you can freeze the video. I'm just going to carry on and give you the answers to these, but if you can freeze the video and try these questions, just to change the subject to the formula, that would be fabulous. I know it's a bit on the small side, but hopefully you can still read that as we're going forward. Okay, so what I've got is a formula here for voltage when in a circuit when the resistance R is in ohms and the current's I is in amps. So V equals IR. So I'll just start with that one there. V equals IR. I want to change the subject to the formula around to say that resistance is equal to, or R equals. So again, I'm going to rewrite the formula around. So I'm going to write it as IR is equal to V. Okay, so all I've done is IR equals V. I want R on its own here, so I'm multiplying IR together. So what I'll do is I'll divide by I on both sides. When I do that, I can cancel out these I's because I divided by I is going to be equal to 1. So R is equal to V over I. So I can work out the resistance if I know the voltage and I know the current. Right, for number 2, what we have is a very familiar one for you. Distance travelled is equal to the speed times the time. So I'm going to start off with distance equals speed times time, st. What I'll do is I'm going to reverse it round because I want to make sure that I'm calculating speed. So st is equal to d. Okay. Right, so I want s on this side on its own, speed. So what I'll do is I'll divide by t on the left, and I must do the same to the right. So what I can do is I'll be eliminating these. So s is equal to d over t. Okay, so speed is equal to the distance divided by time, and that's the way I'll be able to calculate the speed. Now I know you've done a triangle and worked out a triangle for that, but this way here we've just changed the subject to the formula around and worked out a formula for speed. Right, let's move on quickly. Okay, so this one here you may have seen in possibly physics, okay, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. We could think about that as being of a particle. Right, so what we're wanting to do here is we're wanting to change this formula around here to show that a formula for acceleration. So we want the formula to say A is equal to. So let's go ahead and do that one here, okay? Right, so starting off with V equals U plus AT. What I want to do is I'm going to swap them round again, okay? So I've got A on the left-hand side. Doesn't always work for us, but it does most of the time. So what that really would look like would be U plus AT equals V, okay? If I just swap that round. From there, what I'm going to do is I'm going to get rid of anything. The easiest thing to get rid of, first of all, is U, which is kind of hanging on there, just hanging on by an addition. What I can't do is I can't move the T anywhere until I unlock this part here. So I've got to do it in a certain order, and it's the one that's easiest to move. So I've got a plus U there. To get rid of U, remember our formula work? I'll take U away. If I take U away from the left, I'll take U away from the right. So that leaves me with AT, because these get eliminated, and that leaves me with V, take away U. So we're just dealing with letters just now, okay? So, and we're just working it out, just the same as we did with solving equations. Right, I want A on the left-hand side only, so I could divide this side by T, and I'll divide all of this side, so I can imagine that's in a bracket if I want to do that, and divide that side by T, all of it. The T's are eliminated on the left. A is equal to V minus U all over T. Okay, so acceleration is equal to the final velocity, take away the initial velocity, divide it by the time. So I think the first equation of motion, I think that says that acceleration is the rate of change, so the change of velocity there, okay, over time. Right, so here's a couple for you to have a go at. So try these ones and see how you get on. I'm just going to go and mark them, okay? I'll mark them up. Right, so what we've got is we've got a formula for changing centigrade into Fahrenheit, so a temperature thing. What I want to do is to have a temperature that will calculate centigrade when I'm given Fahrenheit. So let's start with this equation here. So F is equal to 1.8 C plus 32. Right then, again, I'm going to just change it around. So I've got 1.8 C plus 32 is equal to F. Right, so let's look at this. So this is similar to what we did in the example. What I'll do is I'll get rid of this part here by subtracting 32 from the left. So I'll subtract 32 from the right. That will eliminate this part and leave 1.8 C on this side and F minus 32. I don't want 1.8 C, so I'm going to divide by 1.8 on the left, and I'll divide everything on this side by 1.8. It eliminates the number there, which leaves me with C is equal to F minus 32 over 1.8. So there's a way that I can calculate the degrees centigrade if I know what the Fahrenheit temperature is. Okay, question 4. Question 4 is the exact same formula as this one here. The only difference is that we're dealing with a fraction on this one here, and that can make it a wee bit kind of more difficult. So first thing I'm going to do is I'm going to change it round to show that 9/5 C, because 9/5 is just the same as 1.8 in the previous example. So 9/5 C plus 32 equals F. Okay, so all I've done is I've changed that round and said it equals F rather than writing it this way here. I'm going to get rid of the 32, so minus 32 from both sides, subtract that. That gets eliminated, leaves with 9/5 C is equal to F minus 32. What I'll then do is, I've got a fraction at this side here, so to get rid of a fraction, I want to get rid of that 5 that's on the denominator down at the bottom. So I'm going to multiply both sides by 5, okay? Multiplying both sides by 5, and I'll multiply this side by 5 as well, okay? So I've got to remember that I've got to keep that together unless I multiply each of these things by 5. So I'm just going to put a 5 at the front here because I'm going to multiply that bracket out. Remember, when I multiply by 5, the 5s are going to cancel. So that leaves me with 9C equals 5 with a bracket. And I could multiply the bracket out if I really wanted to do that. I'm going to leave it as it is just now. Now what I want to do is I want to get rid of that 9. So that's 9 times C. So to get rid of 9 times, I'm going to divide each side by 9. So if I take the 9's away there, because they're eliminated, that leaves me with c is equal to 5 all over 9. So there we are. There's a formula for c. You may see this written slightly differently, just like c is equal to 5 over 9, which is the same thing, 5/9 of f minus 32. So that's a way of sorting that out slightly. So these formulas are the same, the ones we've worked on there. Right, moving ahead. Another one that you'll notice is the general equation for a straight line, y equals mx plus c, okay, where y is the y coordinate, m is the gradient, x is the x coordinate, and c is the y-intercept, where a line would cut through the y-intercept, okay, so the y-axis. Right, so I want to change this formula around to say x is equal to it, and that would allow me to work out the x coordinate if I needed that. So let's go ahead and do that. So I'll start with changing it round again. So mx plus c is equal to y, okay? What I'll do is I'm going to get rid of the c from both sides. So that will eliminate that one and leave me with mx is equal to y minus c. And all I need to do is divide each side by m to get rid of these here. And that leaves me with x is equal to y minus c all over m. So that's that equation sorted out for us. A couple for you to try, and again I'm just going to go ahead and do these. Right, so you can freeze the video and go and do them. I'm just going to go ahead and get the answers for it. Okay, so what we have here is a formula for the time taken to cook a joint of beef of weight W in kilograms. Okay, so if I want to know what the weight would be if I had a certain time to cook it in, then I'm going to go and do that. So let's reverse it round. 45W plus 30 is equal to t. I'm going to get rid of that 30 that's there first of all. So 45W is equal to, these guys are eliminated, so that leaves me with t minus 30, and I'll just divide each side by 45, and that should give me my answer. So W, because they're eliminated, leaves me with t minus 30, all divided by 45, and you might see that in a bracket sometimes, and that's the way that that one works out for us. This one here, so another straight line equation, just got some numbers in there, so it just looks similar to the time calculation. So let's go and work out what x is equal to in this one here. So this is an equation of a straight line. Right, so writing it round this fashion first of all. What I'll do is I'll subtract 5 from both sides. That eliminates that. That leaves me with y minus 5 on the right. I'll just divide by 2 to get rid of that side there. And that gives me x is equal to y minus 5. And we'll divide that all by 2. And that would be an answer to that one. This way here is going to be really, really handy when we try and do some of our simultaneous equations work, which is one of the topics we'll be hitting pretty soon. Or what we can do is, for this one here, we could say that x is equal to, so that's like y over 2 minus 5 over 2, because remember, everything on the top line is divided by 2. And that again would probably look like a half y minus 2.5 or 5 upon 2. So there's different ways to show that. This one here is one that I'll be using as we go forward for simultaneous equations. Right, last one, and we'll just do this one as well. So again, a couple of different equations of a straight line. These ones here are maybe a bit more tricky. Let's go and do them pretty quickly though. Right, so I want to change the subject to x. So 2x plus 3 equals 7y. What we'll do from there is, I'll just get something underneath this one. What we'll do is we will subtract the 3. So there we go. What we'll do is we'll subtract 3 from both sides. And what that does, eliminates there and leaves me with 7y minus 3. Finally, I'll just divide each side by 2 to allow me to get rid of that. And that leaves me with x is equal to 7y minus 3. And that's all over 2. That's that one done, okay? Finally, I've got one that's a bit more complicated here. I've got a fraction and I've got 5y on the left-hand side. So let's work this one out. So I'm going to go for 2/3 x minus 8 equals 5y. Remember, I'm just writing it round so that I've got the x on the left-hand side, okay? Right, I'm going to get rid of the minus 8, and what we'll do is we'll add 8 onto each side. So there we go. So that gives me with 2/3 x is equal to 5y plus 8. I'm then going to remove that 3 by multiplying both sides by 3. And remember, I'll bracket that and put a 3 in there, because that's 3 times both of these things. The 3's are eliminated, leaving with 2x is equal to 3 with a bracket. Okay, that there. I now don't want 2 of them, I only want 1, so I'm going to divide by 2, which allows me to 2 divided by 2 gives me 1, so that'll be 1x is equal to, and we'll divide the right hand side by 2 as well. So x is going to be equal to 3 with a bracket, 5x plus 8, and that'll all be divided by 2. And that's our final answer. Okay. 2 more for you to try, so just freeze the video and try them. I'm just going to go ahead and do them right away. So equation of a straight line here, I've got 3y equals 5x minus 9. I'm going to change it around. 5x minus 9 equals 3y. I'm going to get rid of that 9 by adding 9 to both sides. That will eliminate that. So minus 9 plus 9 equals 0, leaving with 5x equals 3y plus 9. I'll divide by 5 both sides. That will cancel these and leaves me with 3y plus 9 all divided by 5. Okay, and then finally what we'll do is one with another one with a bracket, pretty small to see. I'll rewrite that out for you. 2.5x plus 7, and what we'll do from there is we will change it round the other side. Okay, and what we'll do is we'll get rid of the 7 from the left hand side, we'll move that over to the right. What we'll do is we'll subtract 7, eliminates that, leaves me with 2/5 x is equal to 4y minus 7. From there what we'll do is we'll get rid of this fraction by multiplying by 5 and dividing by 2. Okay, so if I multiply by 5 first of all, and that'll be a 5 times this part here, got to bracket it to make sure I multiply both things out. The 5's are eliminated, leaving with 2x is equal to 5, and that's 4y minus 7 in the bracket. And finally divide by 2, and that will be eliminated. X is equal to 5 bracket 4y minus 7 all divided by 2. So that's about it for this video. Tried to make it as quick as I possibly could by covering quite a few of the examples that you may see today in your work, your classwork. So hopefully you've understood how we go about it. We're just using the information that we gained through solving equations, and this is looking at linear equations and changing the subject. Okay.